Crewton Ramone's House of Math. Probably a good idea to turn this camera on. Alright, so see this one? That's a perfect square, right? That's a perfect square. That's a perfect square. That one's a perfect square. That one's a perfect square. Alright, we're about to do a lesson on radicals. So now, and like I said, go all the way out. This is 1, 2, 3, 4, 5. We just did the first 5 of each one of these. And guess what? You can keep going that way. 36. Right? Keep building squares. You can make a big matrix. But we're going to start here. We're going to start with the first 5. Actually, we've done a little bit of this before, so I'm going out to 5 instead of just 3. And then, like I said, instead of going all the way to 12 or 20, I'm just going down to 5. And we're going to fool around with this. And once you get the concept, you'll have it, and we can do something else. Alright, so, did you write this down? Alright. I'm telling you, that connection just went bad again. I can't believe it. The connection here on Maui, not as good as my connection to New York. Okay. Different trunk line, apparently. Alright, so, or different, I don't know what it is. If this was 1, then that one's 4. But if this one right here, let's say this one right here, we're going to use our imagination, we're going to say this is 2. Well, that's 2, then that's got to be 8, right?
Mm-hmm.
And what's that got to be? Each one of them's 2.
What?
Each one of them's 2. So look. 2, 4, 6, 8, 10, 12, 14, 16, 18. Get it?
Mm-hmm.
Look, I'm using my imagination and I'm saying this isn't 1 anymore, it's a 2. There's 2 in here.
Okay.
I mean, this could be 3, could be 5, could be anything I want. Right now, I mean, you're used to seeing it as a 1, but what if it was a 3? Well, then this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right?
Uh-huh.
Alright. Now here's the thing. So if I have 2 over here, and, oh wait, first let's talk about the symbol right here. That symbol right there, what does that symbol right there mean?
Root.
Square root, there you go. So square root of 1 is what? Square root 1? You're frozen, but I can still hear you.
What?
Okay, so what's the square root of 1? You got a dog attacking you. What's the square root of 1? 1. That's all it is. So right, that thing right there just says count one side of this square. Oh my God, doggy, go down. He hears my voice. That's why it's hilarious. This dog loves me. Is he licking your computer screen? Oh my goodness. You gotta give him a toy and let him go someplace else.
That's funny.
Alright, he is funny. Alright, what about square root of 4? What's that?
2.
Simple, right? What is that? Well, that's one side. Yeah, be careful. I have a cat that's attacking my slippers. I don't know what's going on. I've never seen a cat chew slippers before. Alright, so, oh wait, square root of 4 is not 4. Square root of 4 is 2. Because one side of this is 2.
Yeah.
The dog is distracting me. That's my excuse and I'm sticking to it. Alright, what's the square root of 9?
3.
Easy, right? It's just one side. Alright, I'm not going to keep going because square 4, 5, right? Just one side. Square root of 16. 4. Square root of 25. 5. Oh wait, let's get big. What if I said square root 100? Now what? Oh, come on, square root of 100. What's one side?
10.
There you go. Square root of 100 is 10. Easy?
Yeah.
Alright, well now we're going to go get a little more complicated. What if I said I want, we'll take this one, square root of 8. Well, here's the thing. That would mean that my square over here, can you see that okay?
Yeah.
You're moving again, so I presume so. Would mean that each one of those is a 2, right? A 2, a 2, a 2. So now, if I have this one, I used to have a big green square around here with a 2 on it for exactly this lesson, but it's in the car, I believe. Oh well, I'll use a red one. Do I not have a green square around here? I do not have a green square around here. Really? Really? They're all in the car. I have 3 of them. They're all down in the car, and I don't feel like running down them. What happened? Your dog slobbered you? That's funny. Alright, that's a 2 right there. See that? That square right there? Your job is to tell me what's one side then. Well, if I have a whole square like this, what times what will equal 2?
What?
What times what will equal 2? On a square like this, on this 100 square, super easy. This is going to be, if this is 100, then this is square root 100. And guess what? Square root 100 is just the same thing as 10, so 10 times 10, right, is 100.
Yeah.
Alright, well, I'm asking you, what if this is 2? Then what?
Then be 2 times 4.
Well, if this is 2 times 2, that'll be 4 in there.
I said 2 times 1.
Oh, if it's 2 times 1, I don't even have a square. It would be that shape.
Oh, then it would be 2 would be negative.
Well, let's not get fancy with negatives. What do you think?
The decimal.
Okay, it could be a decimal. In fact, I'll tell you what, you got a calculator handy?
Yeah.
Alright. Punch your calculator and put in square root 2. What do you get?
Let me see. 1.41242135 6.
There you go. Alright. I'll take it. So we're going to write all these down, actually. Let's change the lesson for just a second. And let's talk about square root of 2 is the same thing as 1.4142. I usually say take 4 places, not just 2. And you can do more, but not. So what do we have here? This is a decimal approximation of the square root of 2, right?
Right.
It's not actually square root of 2, because if you did that, if you just do 1.4142, you're not going to get exactly 2 because you cut off all the rest of it. And by the way, it's a radical. So if you were crazy and went on the internet, you could find square root of 2 to 1,000 places. And you'll just see a web page that has like numbers on it for ever and ever, because this never just goes on and on and on. It's a radical. Alright, so we just cut it out after 4 places. Alright, how about square root of 3?
Square root of 3.
Yep.
Square root of 3 is 1.732050881.
808. So, right, I'm writing, you're writing, right? So, this, like I said, these are numbers you should be familiar with. 7320, and then it's 50, and then it's 808. And square root of 4 is super easy. That's just silly. That's just 2. So we're gonna.
508.
It's 508 0. Okay, yeah. So it's 32050808. So your calculator only goes 7 places.
No.
But the whole thing, like I said, this is an approximation. This is me cutting it off. The whole thing is 1.732050808. And that's not even the whole thing. There's more going after that, but we just cut it off. So anyway, we'll just cut it off right there. In fact, we could cut off right there when you get right down to it.
Oh, okay.
Alright, what's the square root of 5?
Square root of 5 is 2.23606.
I like it.
798.
Yeah, I know, and that's another one. Just keeps going on and on and on, right?
I think so.
Yeah. Okay, so 2.23606, right? But 2.236067977, I believe. 67977, yes. If I'm looking at the calculator, not my memory. Okay, and then let's see here. Square root 6, what's that?
Square root of 6?
Yeah.
2.4494.
Yeah. 2.4494, right? We'll stop there again. 2.4494.
974.
Right, and then it keeps going. Right, 43. Okay, so as you can see, which of these two, which would you say is the more accurate representation of the square root of 2? Well, that's a more accurate representation of the number, isn't it? Or that one?
Yeah.
Left or right? Left or right? What do you think?
Backwards.
Yeah, this one, right?
Backwards. Uh-huh.
Okay. Well, here's the thing. So we're going to play, and a lot of times in mathematics, we play with just these guys. But the idea is, in a minute, you're going to have an idea of how big that is in decimal equivalent. So let's say I have this number right here. I have 2. What's one side got to be? Well, it's got to be the 1.4142 times 1.4142 and, some more. And I'd get 2, right?
Yeah.
Alright, what number is that supposed to be?
I don't know.
Yes, you do. We just did it. What number is it supposed to be?
4.
The square root of what, you monkey?
4142.
Yeah, but what's this whole number, this whole thing? What's that number supposed to be? That's our approximation for what?
One.
Wait a minute. What did I just say a second ago? It's our approximation for what number?
2.
2 or the square root of 2?
Square root of 2.
Alright, so isn't this just square root of 2 times square root of 2?
Mm-hmm.
And of course square root of 2 times square root of 2 is going to give me what?
We learned this already.
Well, there you go. So what does it give you? Then why didn't you give me the right answer when I asked you for it?
I had to think about it.
Yep. But thinking is highly overrated. So what is this supposed to be? What's one side of this square?
1.4142.
Alright, and what's that the same as?
2.
The square root of 2. So the square root of 2 times the square root of 2, of course, is... So in other words, if I have the square root of 2, and I square it, what number do I get? I just get 2, right? Correct? No. Okay, are we good?
Yep.
Alright. So now I'm going to ask you, if I have something like this, 2, 2, 2, 2, isn't that the same thing as 8?
Come here. Come here.
Oh, quit playing with the dog and look over here.
Oh.
Isn't this the same thing as 8?
Yeah.
Alright, well then what's one side if I want the square root of 8?
One side is 4. Come here.
Wait a minute, how can one side be 4? How can one side be 4?
Wait, I'm getting
Yeah, you're getting slobbered is what you're getting.
8,
Oh, I like it. I'll take it. But like I said, that's an approximation. So isn't this just a square root of 2 and a square root of 2?
Mm-hmm.
All right. How many of them do I have?
What?
How many of them do I have? How many square roots of 2 do I have right there?
4.
Then try again. Right? How are you counting to 4?
2.
2. So square root of 8 is the same thing as 2 square roots of 2. Make sense? Oh, we lost connection. Alright, no, you're back. Alright, well, you're jerky. I'll tell you what, hang up and call me back one more time. See what happens. You call me this time. That's funny, the connection to Maui. Wow, it didn't even ring, it just tells me he's there. Alright. You're supposed to ring.
Out, could he?
Alright, there you go. See, it starts off fine, and then it deteriorates. Alright, so do you see that the square root of 8 is 2 square roots of 2?
Yeah.
What am I counting? I'm counting this one side. I'm counting this one side of this rectangle right here. Look at your rectangle. You're counting 1 square root of 2, 2 square roots of 2.
I see you.
Alright. Do you feel it?
Yep.
Alright. So now, let's say I'm changing the number, and I have 32. And I want the square root of that. What's that going to be?
Square root of 32?
Yeah.
5.656.
Yeah, there you go. So you punch in your calculator is great, but I want the actual symbols. What am I going to do? Because you're right.
No,
it is.
I did it in my head.
Yeah.
I did it in my head.
Yeah, sure.
I did it in my head.
Yeah.
Yeah.
So what is it going to be? Well,
be
first off, which one of these rectangles, or excuse me, which one of these squares, because they're rectangles, but they're a certain kind of rectangles, they're squares, because all the sides are same. Which one of these squares am I going to use? Yeah.
4.
I get the 4. And how much does each one of these? How much does each one of those have to be?
5.
Wait a minute. How much does each one of these squares have to be?
5.6 plus 8, 5.25.
Yeah, that's what I mean. That's the whole side, right? This whole side would be, what'd you say? 5 point what?
5.568.
5.568. And wait, one more decimal. 5.568 what?
5.
Okay, but see, that's an approximation, and that's about how long this would be, about 5. But if you want to be exact, tell me in how many square roots of 2 would that be?
Let me think about it.
Well, how many do you have? Don't I have?
4.
4. 4 what?
4 square roots of 32.
Wait a minute. 4 square roots of what?
4 square roots of 32.
Cannot be 4 square roots of 32. There's no way that the square root of 32 is
Yes.
4 square roots of 32.
Yes.
No possible way. That makes no sense.
That makes sense.
So what does it have to be? What does each one of those squares have to be? I'm recording this, you know. Oh, we'll cut it off like that. There you go. So isn't that 4, 4, 4, 4? What's each one of these squares?
1.
What's each one of these squares?
Oh.
Oh.
5, 4, 2, 5.
Okay, well that's the whole thing, but what's each one of these squares? Isn't each one of them have to be 2? Doesn't each one of them have to be 2?
5.656854.
You're correct, and like I said, that's an approximation. I don't want an approximation. I want it to be exact.
Yeah, that is exact.
That is not even close to exact because you got to cut it off. Right? I said that's not even close to exact because you got to cut it off. These are radicals. They go on forever. They go on for thousands of places. So exactly, not exact.
I cut it off, and the answer is.
Yeah, see what I mean? Why do you get to be the one that tells me? So what I'm asking you is how many square roots of 2 do you see there?
4.
4 square roots of 2. That is an exact answer. Yeah, you said 4 square roots of 32, you silly goose.
I said 2.
Alright, so do you see what it is? It's 4 square roots of 2. Right, and that's very exact. Oh, wait, just for fun, tell me what it was again. So 4 square roots of 2 is approximately, so you see that's not an equal sign, those are curvy lines, is approximately, what did you say, 5 point what?
5.656854244949.
There you go. See, I even lost it. 5.6568, blah, 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 right? Okay, that's not as exact as 4 square roots of 2. But, you know what I bet you could do? Take the square root of 2, and then multiply it by 4, and I bet you get this number. Betcha. Try it.
Take the square root of 2 and multiply it?
Yeah, 4 times. What are they measuring? You guys building something? I can hear the tape measure in the background.
The square root of 2 times what? 4?
Yeah, that's what it says right here.
5.6568.
See, there you go, right? There you go. It's the same number. So, in other words, one side of a 32 square is about 5 and a half and a little bit more. Right, because a lot of kids look at, a lot of children look at 4 square roots of 2, and that doesn't mean anything. This means more to them because it's a decimal. Make sense?
Oh.
Alright, so what I'm saying is that this right here is that one side. Yeah. Alright, you. Well, let's see you do one by yourself. I don't want an approximation, I want the exact result.
I bet.
Can you do it?
Yeah.
Alright, so now here's what you have to think. Remember we did in the very beginning, we made that table that had all the different numbers in it, right?
Yeah.
Alright. So I'm gonna ask you for, you want a hard one to start or an easy one?
A medium.
A medium, alright. Then I will ask you for square root of 27.
Take that and do that.
I want the exact result, not you punching your calculator.
5.1.
See? That's what I mean. I want the exact result.
That was.
Which one of these should you use, do you think?
The 5.
Really? I'm going to be able to get a 27 out of that?
No. I meant to say the 3.
Okay, good. I like it. And then, if this is the 3...
There's the autocorrect.
There you go. Yeah, you have an autocorrect on your... wired into between your brain and your mouth?
I meant the 3.
Alright, cool. I'll take it. So, now... So now, what does each one of these have to be?
5.19.
Wait. Each one of these squares. What does each one of these squares have to be?
1.
Oh, can it be 1? If each one of these squares is 1, then this would only be 9, and I said it's 27.
Let me think about it. Oh, 3.
There you go. So how many square roots of 3 is that going to be?
3.
Yeah, 3 square roots of 3.
Square roots of 9.
Square roots of 3.
Oh, square roots of 3.
Right, because each one of these squares is 3. 3, 3, 3, 3. Pay no attention to the fact that I can't draw a square. 3, 3, 3. So what do I have? I have a square root of 3. I have another square root of 3. I have another square root of 3. This whole thing is, oops, Great. I really need to put gloves on or something. 27. The whole thing is 27, right? Okay, because I'm using my imagination that each one of these squares is 3. The whole thing is 27, and one side is is 3 square roots of 3. All right, try do one where you don't use any autocorrect and you get it right the first time without me asking you. All right, you ready? Ready? Now, did you write down that first table? You? The one where I did 4, 8, 12... 16, 20, alright, well then you should be able to find it on there and you should know which one I want. Alright, so now I want square root 75. Which one should I use? Ooh, I like it. He's thinking.
The 16.
The 16? Am I going to be able to count to 75 with a 16 square?
No. Oh, the 3.
The 3?
The 9.
How can I mean the 9? 9. I'm never going to count to 75 with 9s either. 9 times what is 75?
Oh, the 1.
Well, boo. Try again. Out of this 3, really, you're going to have... okay, we'll just think for a minute. The 4s, I'm never going to be able to count to 16 by I'm never going to be able to count to 75 by 16.
Well, I just said every table.
Well, you didn't say that one.
I did say that one.
You did not.
Yes, I did.
My favorite part about this is it's on video, so it's hilarious. You cannot gaslight me. So... so, which one of these am I going to use? Pick a color. The green one, the orange one, the pink one, the yellow one, or the blue one?
The blue one.
I like it. Bam. Now, how much does each one of these have to be?
5.
Well, if it was 5, it'd be 125.
1.
If it was 1, it'd just be 25.
Oh wait, 25. Oh, 3.
3. There you go. Were you eating food with lots of food color in it again? Did that happen?
No.
Okay. Then I can't come up with it.
Stromboli.
Okay. Okay. So now, what am I gonna have? How many? You know it's 3s, so how many square roots of 3 am I going to have?
I don't know.
Yes you do. That's actually pretty cool. Try hold it still. Can you hold it still? I'll take a picture of it. A little further back, just a little bit. Because right there it's just green. A little bit more back. Not too much though. No, the other way. Yeah. Alright, I took a picture of it just for fun. Anyway, okay, so, what am I going to have? Give me the answer. The correct answer.
3 square roots.
Wait a minute, how many square roots? If you can count the 3 there.
5 square roots of 3.
There you go. Now we're cooking with gas. 5 square roots of 3. And here's how they're going to teach it to you in school. Ready?
Okay.
So you can notice this when you see it in school.
Okay.
They're going to tell you, alright, so you got to make a square number because we're talking about squares. So what I'm going to have over here is underneath this radical, is what we call it. We're going to have 2 things. Here, let me go. We're going to have 3 and 25, right? So 25 times 3 is the same thing as the square root of 75, right?
Right.
Okay, well, do you know the square root of 25?
5.
There you go. So square root of 25 times the square root of 3, and then what I have is 5, but I don't know what that one is, so it's just 5 square roots of 3. Same answer. But they make you get there in a crazy roundabout way, where this is just, boom. 1, 2, 3, 4. Each one of these has to be a 3, right? Draw this picture over here.
Right.
Right, draw a picture.
Yeah, drawing a picture.
Make a square. Ugh, that's pretty good actually. Oh my goodness. Every once in a while, I do alright.
Right.
Okay, bam. And each one of these is a 3. And I'm not going to put all the 3's in there. 3, 3, 3, 3, 3, 3, 3. And the whole thing is 75. But each one of these is a square root of 3, 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 and a square root of 3. That's one side of that. Because that's what we're talking about. That's what this whole symbol means, is one side of a square. Quit fooling around with your blocks, get a pencil, and everything that you see right there, copy it down.
Okay.
Okay.
I have a lot of used paper.
Good.
Right there, this one. Okay.
The afternoon sun is setting. Is it cold down there? I notice you're wearing long sleeves.
Yeah.
Yeah, it's been chilly. But this morning at 11:30 in the morning, right? Almost noon. It was 66 degrees in Makwa.
Ooh.
That's a little too cold for most people in Makwa. I mean, in the middle of the day, with the sun shining down, it was 66 degrees. That's not right. It should be 81 or 82 degrees. And it should have at least been 70, I mean, for Pete's sakes.
Okay, I wrote it down.
Alright, so you understand all this stuff? Let me hold your, instead of holding a block up to the camera, hold your, what you wrote down up to the camera. And you're frozen at the moment, so we gotta, there you go. Bro, you never write down nothing. So, write down the rest of this.
Alright.
You naughty camper. Is your mom there? No popsicles for you. It's so ridiculous. The call starts off. The call. Okay, now wait. You hang up on me, and then I'm gonna call you back. See if we can get a connection going the other way. So here, just hit the hang up button, and I'll call you back in 2 seconds. We're basically just resetting the call. There you go. Yeah, see, this thing's messed up. In fact, you know what I'm gonna do? I'm gonna do this. I'm gonna refresh this whole page. Alright, it liked that. And you're there. And now let's see what happens. Oh, it won't connect. Wow. And let's get another problem going. Ugh. I'll tell you what, we'll pause while we wait. Okay. So, you tell me, what? Just, and pick your camera up. I'm looking right at the table now. I can see, oh, nice, I like it. Oh, wait. Go back. I'll take a picture of that too.
What?
Your whatever the heck that is you just built. What did you build? You just stack some blocks, I like it. I'll take it. Wait, you were fine. There it is. Okay. So, what's the square root of 36?
square root of 36.
Mm-hmm.
Oh!
Oops. That's funny. Square root 36. And it's going to be time to do something. And the next time I see you, well, I'll see you in person, almost guarantee for sure. Just so happened I wasn't going down country today, so more easy on the computers. Aww! Aww! Getting big too. That dog is very cute, but oh man, it's growing like exponentially. They have a couple of cute pit bulls.
Fine, cool.
There you go. All right. Well, see here. Take the. There you go. Turn it that way. And tell me, what's the square root of 36?
Square root of 36 is 6.
There you go. Done. That's easy. I like it. What's the square root of 80?
Square root of 80 is 8.94.
I like it. She punches his calculator. I want the exact number. I want the exact number.
In my head.
Yeah, you did in your head. We could do a lesson where I can show you how to do something. I can show you how to approximate these in your head. It's a lesson I do very rarely.
Is that right? I use the force.
You use the force. Tell me the square root of 80. Which one of these am I going to use for 80? What do you think?
Wait, let me think about it. 32, 40, 8, 16, 24, 32.
Yep. I can tell.
Oh, it's 10. That's
it's so not 10.
10 square roots of each.
Ooh, close.
Oh, 10 square roots of...
How are you getting 10? How are you getting 10?
Oh, no. 10 square roots of 8. No, but 8 square roots of 10.
Alright, close, but no cigar. Use this one, or use this one. Can you see that if I use this one, we could go two ways about this. I could say that each one of these is 20,
it's 2
40,
40,
60, 2 square roots of...
2 square roots of 40.
2 square roots of...
2 square roots of 40.
What's 1 square?
40.
What's 1 square?
40.
Just 1 square. 20. There you go. So what's 20. It going to be? 2 square roots of 20. Now we have a problem.
Yep.
Is that I can do square root of 20. So what's the square root of 20? Well, doesn't that have to be a 5?
I think so.
5, 10, 15, 20. So then 20 is 2 square roots of 5.
20 square roots of 5.
2 square roots of 5.
I think that's wrong.
Which would give me 4 square roots of 5. Try to take the square root of 5. Here, quit fooling around with a tape measure.
Oh.
See? See what happens? Anyway. Take your calculator and punch square root 80.
Oh, square root of 80? You think about it in my head?
Yeah, sure.
8.442711.
8.44271. We'll quit right there. Alright.
Okay.
Well, let's see here. This says 2 square roots of 20. So take the square root of 20 and then multiply it by 2 and see if you come up with that.
Square root of 20 multiplied by 2. Square root of 20 times 2 in my head is 8.9442719.
It's not the same. You had 8.44271, and is that right?
Oh, 271. Yeah.
Yeah. Is it? Wait a minute. Is it 8.44 or is it 8.94?
8.94.
All right. So this should be a 9 here. All right. So wait a minute. This number, what you're saying is this and this one are the same.
Mm,
You gotta write it down.
I wrote it down.
Alright, so let's see here. The thing is, 2 square roots of 20, that's the same thing. Well, this would be the same thing as 2 times 2 square roots of 5, which would give me 4 square roots of 5. Oops. I don't like that answer either. Oh wait, yes I do. Because 4 square roots of 5, if this was 5, if each one of these was 5, 1, 2, 3, 4, 5, pay attention over here, you monkey. This would be 5, what's 5 times 16?
5 times 16 in my head. 5 times.
You should be able to do 5 times 16 in your head.
80.
It is 80.
I did it in my head.
Alright. So look, we got the answer 2 different ways. Now, see, you should have used this in the first place. And each one of those would have been... Here, let me use a different color. What color shall I use? I'll use green just to make it look cool. Each one of these should have been 4. I would use yellow, but yellow doesn't show up in the camera at all. Let's see here. So this is 5, 5, 5, 5, right? 20, 40, 60, 80. And I'd have 1, 2, 3, 4 square roots of 5. But if you put down 2 square roots of 20, first off, you'll never see that on a test. You'll never get the right answer. And if you put that down on as a test question, they're going to mark it wrong. Because they're going to want that instead. Because it's not 2 square roots of 20. Because we can reduce, as it were, we can simplify the square root of 20 to 4 square roots of 5. There it is, right? Look over here. 5, 5, 5, 5. That's 1, 2, 2 square roots of 5. Is the same thing as a square root of 20.
Yep.
So if I have 2 square roots of 20, which is the same thing as 2 square roots of 5, I wind up with just multiplying, because this thing right here, this is one number, so it's 4 square roots of 5.
Right.
Make any sense? I'm looking right up your nose. You're ridiculous. Anyway. Just for that, no more tablets when we do this. You're ridiculous. Anyway, at least your nose was clean. That's good.
Uh-huh.
Yeah. All right. Let's do some problem solving and call it a day.
Okay.
All right. But like I said, doing these square roots with radicals and being able to do radicals and perform basic operations with radicals, you're going to have to be able to do those. Guarantee it. There's going to be a chapter in your book coming up.
Okay.
All right. And because what they're going to do is they're going to make you multiply radicals, they're going to make you add radicals, they're going to make you divide radicals, right? Because it's basic operations with these numbers that are called radicals.
Yep.
Alrighty. Let's do, like I said, some problem solving, because you still need a little work on that. You were rusty last time we were fooling around. Alright. Solve for x. Are you ready?
Okay, I'm ready.
3x minus, I don't know, 9 is the same thing as 2x. Oh, that's too easy. Let's go with 5x minus 9. There you go. And then we'll make this, we'll make it a whole number, not a fraction, because I know how much you love fractions. So we'll just make this a whole number for the time being. And we'll call this, I don't know what we'll call it. We'll call it 18. What does x have to be? Solve for x. What is x? What's the 2 tools you're going to use every time? Hero 0, no funky back to 1. Hero 0, no funky back to 1. Just no. Hero 0, no funky back to 1. Alright, so write it down, solve it. I don't want to hear about steps, nothing. Just tell me what x is.
Gonna do minus 2x minus 2x.
I like it. I can hear you. Yep, there you go. You took away 2x. I can hear you doing it. Take away 2x. Then what?
1 by
What about this?
equals 3.
What about this?
X equals 3.
X equals 3. Okay. Did you add 9 and add 9?
Yeah.
And then you wound up with 3x equaled 27. And how did you get x equals 3?
Oh, I did minus 9. Oh, 327, and then X equals.
Well, how did you minus?
I don't know, man.
Yeah, I do. I know what you did. You just decided, right? Okay, so you can't. Right? Okay, that would be. You see, your answer is going to be way off from what I did. So the difference between x equals 3, which would be not the right answer, to the difference between x equals 9. And now check it. What's 5 times 9?
5.
Just do the math.
45.
Okay, 45 minus 9.
Mm-hmm.
What's 45 minus 9?
45 minus 9 is 36.
Right. What's 2 times 9? Well, 18. What's 18 plus 18? 36. So 36 is the same thing as 36 when x equals 9. All right. I'm going to give you another one because, like I said, you're still a little rusty. You came up with x equals 3, and x equals 3, that wouldn't work.
Okay.
All right. Right, you gotta get these to the point where they're crackers, where it's like you look at these and you're happy because you know you're gonna get the answer.
Okay.
All right. Tougher one. 7x. We'll go minus again. Minus, I don't know, let's do 16. Is the same thing, and we'll make this, just for fun, negative 2x. And that'll be, let's see here. I'm going to think of a good number that I want to put over here. I'm going to make this plus. Let me do some math over here. Let me make it fun. Oh, we'll make it not too fun. 56. And here, we'll make it fit. Oh, I'll tell you what, we'll do the whole thing. 7x, let's move it over. 7x minus 16 is the same thing as negative 2x plus 56. Did everything fit all the way to the end? Can you read it? Yes, you can. All right, go to town using your super duper problem solving skills. Complete freeze.
I have no idea what.
You have no idea what to do? What? Huh?
No. Something just happened. It said crash, it crashed, and it said crash recovery, send help for crash recovery.
Oh, don't do that. Here, I'll tell you what. Just restart the. What device are you on?
Tablet.
Okay, just restart your tablet. Turn the thing on.
Oh, no, it's fine now. It restarted it, so.
Okay. Well, I'm telling you, it'll work better. Just take a second and restart your tablet. Just like I said, turn it off, turn it on, and then you're gonna have to bring up Google again and so on. But I mean, just restart your tablet. Something crashed on your thing. Takes 2 seconds. We only got like 10 minutes of class left anyway. But anyway, just restart your computer. It'll be easier. Or restart your tablet.
We're past our time.
Not. We didn't even start till like 5.
4:16.
We started at like 5:39 or something.
Oh no, we started at 5:16.
Did we?
Yep.
Oh, well then we are past time. All right, so solve this one and we'll quit.
Okay.
Yeah, because I forgot to turn my camera on in the very beginning of class and everything. So anyway, that's why we don't have. Anyway, it'll be fine. All right, so just solve it.
Wow, it's a big number. I don't know if I can do it.
Oh my goodness, please.
Wait, I'm still doing the problem.
All right, I know. And then again, my only homework for you, even though you're a big boy at 13, is practice your multiplication table so that you have no issue with multiplication at all. And so when I ask you, oh, what's 5 times 16, you can just do it in your head. Bam, 80.
It's 9x equals 40.
Hold on a second. What are you doing over here? Are you subtracting 16 over here?
Mm-hmm.
Why are you subtracting 16?
Oh, I have to add it. My bad.
Yes, you're bad.
I forgot about it. I didn't see it.
All right, yes, I know. If that was plus 16, then you would be right. It'd be 40.
Okay. Is 9x equals 76?
9x equals how much?
76.
How are you getting 6 and 6 is 6?
What?
That's what I said.
72.
There you go.
72.
There you go. Now what? No fun, get back to 1.
It's 8. X equals 8.
I like it.
Yep.
I like it a lot. Let's put the therefore.
Yep, that's that.
There you have it. Now, just one last thing. Check it and make sure you're right.
Yep, I checked it.
Oh, let's see you check it. Let's see you check it.
I just lost the stash paper.
Yeah, see how it is. Oh my God. It's like teaching a petulant 8-year-old. It's awesome. Anyway, 8. And over here, this is also 8. What number is this and what number is that? And then we'll quit.
Negative 16 and 7.
Wait a minute. What's this number? What's 7 times 8?
56.
Oh, and what's 56 minus 16?
40.
40. Ooh, so your subconscious mind knew something was going on here. And then what? Over here I have negative 16.
Negative 16.
Plus 56 is?
40.
That's it. 40 equals 40 all day long.
Yep.
Alright. Okay, so like I said, what's your homework?
Practice problem solving.
Mm.
Graph numbers.
Okay, yeah, but no. Better than that. Just practice multiplication.
Okay.
And when I'm serious, like listen, you know how you can listen? Just go to my website, go to the Multiplication Rock page, and just listen to Multiplication Rock songs. And if you don't like the Multiplication Rock songs, then fine, just go on the internet anywhere and just put multiplication songs. There's plenty of people that made multiplication songs. There's a couple of guys that made some cool multiplication songs that like it's current music, you know? And they just changed the word to be multiplication tables. I'll send you a couple online. And then, like I said, just practice multiplication. I'm telling you, that's a number. That's like, do you do any martial arts or anything?
Nope.
Oh, okay. Did you ever watch Karate Kid?
Yeah.
Alright. Wax on, wax off. What is he doing? He's practicing. He's practicing how to block, right?
What do you mean? It's the jacket. It's put your jacket on.
Okay, so you saw the new one where he's putting the jacket up. Alright, fine. That's the one with Will Smith's kid. Alright, fine. Whatever. But the idea is...
Will Smith's child.
Yes, Will Smith's child. That's the right answer, except in Will Smith's case, that's a kid. But the idea is, unfortunately, but the idea is practice your multiplication. Oh, just practice your multiplication. I'm telling you, out of everything, that's going to make the biggest difference for you.
Okay.
You know why?
Why?
Because multiplication allows you to count quickly. That's it.
Yep.
Alright, so practice your multiplication tables.
I can count fast.
Especially your square numbers. Alright, if you can count fast, what's 16 times 16?
Oh, not like that.
See? You should know that one, right? My boy has that memorized, I guarantee it.
I can do it.
Okay, let's do it. One fast one. We're supposed to be hanging up, but that's alright. I got time.
Okay.
16 squared. 16 times 16. Well, I can look at this. I'll draw a picture. I'll draw that. That makes it even easier for me. And then I know that's 36. So let's see here. That's 100, right? 120.
Oh,
and 36. Oh.
No, not 2. Oh.
Ugh. Don't hurt yourself. Right? 60, 60, 100, 36. Bam, there it is. 256. See, I can count quick.
I can count pretty fast too.
All right, well, you got to get up there so you're close to where I am. So just practice. That's the only thing to do is practice. I'm sorry, there's no other way around it. It's not. I have no magic to make it so that it goes in your head. You just got to practice. And then what you will see is that, bruh, all the rest of your math gets easier.
Okay.
Okay. Alrighty, I'll see you not next Monday, but the Monday after.
Okay.
Alright, take it easy.
Okay, bye.
Bye.
Thank you.
You're welcome.